So my first video, let's see how it goes. All right. 1381. Today question is design a stack with increment operation. All right, that's interesting. All right, so design a stack that supports increment operation of its element. Implement the custom stack class. Custom step int max size with max size, which is the minimum number of elements. Okay, so we can do this with an array or an array list and always check if the max size, but array is probably best. Push add X to the top of the stack. That's fine. Pop removes the top item and then decreases probably. Pops and returns, yeah, because you gotta reduce because it pops the element, right? You have the stack. It's open, where is it? Let's open paint. Show here paint. This is our stack. Boink, boink. Boink, we have max size here. Okay, this is our max size. The stack, when it's initialized, at least for memory in Java, is like that, right? And then we have all these dot, 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 dot. All right, so we start putting elements at the bottom. We put 1, we put 3, we put 4. Actually, I don't like this. I like this. 1, 2, 3, 7. I don't know, something like that, right? When we pop, we get the last element, pop, and this returns 7, right? That's it. That's Z, 7, right? Okay. And then we remove 7 from our stack. And this is called pop, all right? So this is how we have to pop. And then push, here we have void push. We call push. We put 12. And because we removed 7, 7 is gone. Zoom, zoom, actually, zoom, zoom, zoom. We are going to put 12 here. And if we call again pop, we're going to return 12. Okay, that's how it works. Let's see. Basically, the stack, the only thing is different than a regular stack is this thing, void increment. We have to select k values, k elements, and then increase it by value, right? Yeah, makes sense. So if we go here and we call our stack, we call our zoom, we call 1, 2, 3, 4. Let's do k, it's equal 10, right? K is equal 10. We have to make sure that increment if there are less than k elements in the stack, increment all elements. So it's here, read this. This is important. This, we have to do a minimum, right? We have to call a math.min. We have to do min between what? K and probably size, right? Okay. Which size probably it can be like a pointer, sort of like a pointer or an index to, that's a nice arrow. I don't know why I like that arrow. We got a point. We got a point to our yeah, it's basically 0, 1, 2, 3, 4, right? Our, this is called top, all right? Or whatever we can call it, but this is the top, and we have to do the less, like the minimum between k, because k is over here, k is big, k is, it's 10, 20, I don't know, it depends. And the size, which in this case we're gonna call top, right? Top. And top is also necessary for pushing an element, right? We need top to be incremented. And yeah, okay, makes sense, makes sense. And then this is a little bit um It's a little bit chaotic, but wait, element, boom. All right, so we have three methods, right? We have three methods. We have push. Oh wait, we have to also initialize the array, right? We're gonna initialize the array. I mean the array. We have to initialize our class custom stack, right? So when we initialize our class, we have to basically create an array. It's gonna be equal to what? It's gonna be equal to a new integer array of what? Of size equal to max size, mx, max size. Okay. And then because the array is empty, we need to put top equal. We can put top equal 0, but I actually think I'd rather do it less. So if it's -1, it's gonna be empty. If it's 0, it means that it's gonna basically top points to the last element inserted. That's it. Okay. And we just do it like this. I might have to correct this. I don't know if I want to put 0, -1, but let's put -1 for now. See how it works. Then, and that's then we have push. Push is an element X. So basically what we do with push, we want, okay, so we basically want to, how are we doing this? Oh, we have to check if, how spell if. So basically we want to check if top, maybe I should write this because now I'm getting a little bit confused. Top, it's less than size. I believe it's -1, right? Because let's say the amount of elements is like 10, right? And we have top at 9. We cannot put another element, right? Because top is pointing at the last index, right, of our array. The array is already full. Like if we put another one, we're going to increment top to 10 and then add an element in position 10, but position 10 doesn't exist because this is the length. So the numbers goes from 0 to 9, right? Which makes very sense. Okay, so if top size is -1, then what we have to do, we basically have to add an element in the position top. But first, adding it, we have to increment top. So our array of plus plus top is equal x. And we're adding the element. And we're also incrementing top like this. And that's it. That's all it has to do. All right, let's start writing these two. Okay, so we have int r, let's call it r, and then we have int top. So when we initialize, we go r equals new int of size max size, and then we're gonna put top equals 1 -1, right? We're just gonna do this. Now we're gonna do push. So if top is less than r dot length, You don't have to do that. We have to do just r of plus top. It's gonna be what? It's gonna be equal to x. It's gonna be equal to x. We said -1 right here. So we are also incrementing top. So we're good. We're good. Okay. Public int pop. All right. So we did those two. We can remove this. And we just have to think about pop now. I believe that's right. Something's fishy. I don't know why. Okay. All right, so we have to pop. Basically, pop is if top it's greater than -1, right? Because like this, we don't know if it's empty. So if it's greater than -1, basically return. What does it? It's -1, right? Pops and returns the top of the stack of or -1 if the stack is empty. Yeah. So return r of top. We have to decrement top because we're removing an element, right? But we have to decrement it afterwards. So we do top minus minus. So we return the element at position top and then we make top -1. Okay. And then return top else. I can write this in one line with the arithmetic expression. Arithmetic. I don't know. How do you say that? That's interesting. Expression. Yeah, return array top minus minus. Else, what do we return? -1. Okay, that's easy. All right, let's write that down. So return, okay. Top greater than -1. Okay. Is top greater than -1? Question mark. Yes, it is. So you're gonna return array of top minus minus. Or we're gonna return -1. You like them apples, huh? Sounds pretty cool. I believe this is correct. Hope so. Okay, increment. All right, so we did increment before. We basically did a little brief about increment. Nope, this is not what I wanted to do. This is what I wanted to do. So basically we have to do k is gonna be equal minimum between what? K and size, right? Or length. I don't want to spell length with the mouse, too long. So we're gonna just put that. All right. And then for each element, wait, is it k? Oh, no, 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 no. It's not size. It's top, right? Top. But is it top +1? Because top is pointing to the last element, right? I believe it could be top +1. Huh. Should be top +1, right? Because top is pointing to the last element, so it should be top +1. All right, let's figure it out. So k equals math.min between what? Between top and remember it's not top plus plus, because if I do top plus plus, then I increment top, and that's wrong. And k for int e equals 0, e minus k, e plus plus. Hmm. Yeah, because if I add one element, top is gonna be equal to 0. But I don't need. Yeah. And also the problem that I'm thinking about is the array is not null. The array is made of 0 numbers. So I don't want to go over top because then I'm going to increment by, in this case, for example, when we call 5 to 100, right? We're calling increment 5 to 1, first 5 elements of 100. We are making maybe an error to increment a number 0 that is technically not supposed to be in the stack. So, okay, that's interesting. All right, let's do this. R of A, R of I is plus equal. What? Well, I think this is fine. Yay. Okay. Can I submit it? Let's go to test cases. I think it's fine, right? Let's take one test case, this last one. All right, let's submit. Let's go. Yee, looks like it's correct. Ooh, 100%. Really? Increment array. Wow. I don't know. This is very mystical for me. But yeah, I did it, and it took me 4 milliseconds. It beat 100%. So yeah, that's pretty good. Not gonna complain about it. Hmm. Okay. Nice. All right, we did it. So that's how we do this exercise. I did already a submission here. I did this before. Wait, what is it? This one, but that was horrible. I did it with linked lists, but it's not good. Definitely not good. Yeah, linked lists are not optimal for insertion and deletion, especially when you have to pop something, right? Because you have to parse the linked list, the full linked list, and nah, it's not good. But this is the one I did, right? This is like the same as I did. Usual, yeah. Whatever. Why mine is faster than his? This is like the same exact code, but mine is faster. Whatever. Okie dokie. All right. I'll end the stream now.